this is Captain Chaudhari. In my series of videos on marine astronomical navigation, today I'm going to talk about certain interesting things about these planets, in particular the Venus. Venus, as you know, is a navigational planet. It's an inferior planet, and its orbit therefore is within the orbit of Earth. Now, first I'm going to talk about these motion of these planets, that is the apparent motion of these planets. Let's first look at the apparent annual motion of the Sun, which is eastwards, how it becomes eastward. Let us say this is the orbit of the Sun, elliptical orbit of the Earth, and Sun located at one of the foci. The Earth goes in an eastward or anti-clockwise fashion as seen from north of everything. Now, when the Earth is here, suppose this is the celestial sphere. When the Earth is here, the Sun would be seen here. When the Earth comes here, the Sun would be seen here. When the Earth comes here, the Sun would be seen in this direction, and so on. So we find that the Sun takes an anti-clockwise path or eastward path in the sky. Generally, whether we talk about the planets or Sun, an eastward motion in the sky, in the celestial sphere, is considered direct motion, right? So this is how the Sun would appear to go from one constellation to other constellation, in case we could see a movie in fast forward whereby Sun could be seen along with the stars in the background. We would have found that Sun changes the houses. 12 houses are there in 1 year. And this movement of the Sun in the sky, that is the yearly movement of Sun in the sky, is easterly, and this is called direct motion. Now let's look at the planet. First, the Venus. Let's say you have the Sun here, and let's say this is the orbit of Venus. Orbit of Venus is within the orbit of Earth, and because the orbit of Venus is within the Earth's orbit, we say that the sidereal period of the Venus is faster than or smaller than that of the Earth. For a certain observation, we may assume that because the Earth moves slower than Venus, let us assume that Earth is fixed here, and it's only the Venus which is moving. Say we may start the journey of Venus from here, right? And let's say this is the celestial sphere. When the Venus is here, we'll call this position as V1, and although very close to the Sun, if the Venus has to be seen in the celestial sphere, it would be seen over here. Now when Venus comes here, we will find the Venus to be here at V2. You know, this particular movement, as you see from top, is anti-clockwise, and that's why it is eastward, and that's why it is the direct motion. When the Venus comes here, probably it looks like maximum elongation on the eastward side, right? The Venus would be seen here at V3, but when the Venus comes here, you will find that the Venus is seen over here, maybe at V4. So you find that the Venus has traveled eastward in the sky, and then it again starts traveling westwards, and you will find the Venus to be here later on, and then over here later on, and then over here, and then over here, till the Venus is seen like this, whereafter again the movement of the Venus will be eastwards, right? A mariner out at sea must definitely try to witness what is this retrograde motion or direct motion of Venus. Like there is this planetary diagram that is given in Nautical Almanac. It shows the position with respect to, I would say it shows the elongation. Elongation means the distance from the sun, distance from the direction of the sun. So when Venus is very close to the sun, of course, you cannot see the Venus because they would rise or set almost at the same time, and it would be too bright to see the Venus. But two things. One, the navigator, the mariner must definitely try to see the Venus through the sextant in daylight. And that's very, very important because otherwise his job out at sea is not done. Okay, another thing is, from this planetary diagram we also can make out when is Venus in conjunction with say Mars, Saturn, Jupiter, etc. That also can be found out. But the main thing which I want to tell you is, from these diagrams you can make out that Venus would attain the maximum elongation at this particular time. It is at that time that the movement of Venus in sky would change from eastwards to westwards or westwards to eastwards. This movement of the Venus is not like Sun. Sun is permanently seen going eastward in the annual, but Venus sometimes eastwards, that is the direct motion, and sometimes westward, that is the retrograde motion. The period of revolution of Jupiter is 11.86 years. Jupiter is 5.2 times the Earth-Sun distance from the Sun. So for a small observational period, we may assume that the Jupiter is fixed over here. As if Jupiter is not moving, it's only the Earth which is moving. So when the Earth is over here, we'll call that position E1. And when you look at the Jupiter in the sky, Jupiter appears here. We'll call this position as J1. When Earth moves from E1 to E2, we say that the Jupiter would appear in this position J2, which means that Jupiter is moving in anti-clockwise direction. When Earth comes here, the position of Jupiter would be E3, J3, this is E3, and when Earth comes here to E4, the position of Jupiter appears over here. This is J4, which means that the Jupiter which was seen moving eastward, suddenly the movement direction is changed, and as if the Jupiter is moving eastwards, westwards. So this is called retrograde motion. The eastward motion is called direct motion, and the westward motion is called retrograde motion. And when the Earth comes here, you will find the Jupiter here. When Earth comes here, you will find the Jupiter here. So you can see that the Jupiter is now moving in westward direction, right? So Jupiter shows both the motion, that is the westward motion as well as eastward motion, the direct motion as well as retrograde motion.